First of all, thank you all for coming. And I know that this is 4:30 in the morning, in the afternoon, maybe the last session. So thank you all for coming. So in the next 20 minutes, we're going to cover that how the innovations on Google Cloud Storage, how that can help you to power your AI and analytics. My name is Jason Wu. I'm the product manager for Google's Cloud Storage, as well as some of the other storage products at Google. So let's get started. I think this picture is probably looks very familiar. It's I don't have to repeat a lot of this. The Google Cloud Storage, it's an object storage service. It's also commonly known as a GCS, if you have used and heard about this before. So it provides the unified data platform, unified storage platform for all of your analytics workload and all of your AI workload. It does support all of the open data format, like Iceberg, Hoodies, and the Delta Lake. With that, with the open data format stored on top of cloud storage, you can leverage all of the compute, all of the different analytics engine as you please. So there are many of those engines are offered on top of Google Cloud. So you can either use some of the first-party ones or the third-party ones, or you can build your own as well. These are just some examples how our customers are leveraging cloud storage, GCS, to build their open lake architecture. We have some of the customers like Spotify, they're leveraging the first-party services provided on Google Cloud, like BigQuery, Big Lake services, on top of the GCS data. We also have customers like Michel who are leveraging third-party, like Databricks technology and analytics engine to process and analyze the data they have on GCS. And we also have some of the very large customers like Uber. They basically build their own data analytics on top of GCS. They're leveraging a bunch of different technology as well as some of the open source and homegrown technology. So, having your data in an open data format stored on GCS, stored on cloud storage, really gives you a lot of the options and the flexibility, and lowers the cost for all of your analytics and open lakehouse architecture. So to build an open lakehouse architecture, there are a number of different challenges we have to overcome. The first one is it's wonderful to have the storage and the compute disaggregated, and you can scale them as needed and as separately. But then the challenge comes in, say, how do you get the maximum performance out of it? How do you collocate your data and the storage as much as you can so that you can minimize the latency, as well as minimize the data transfer cost, getting the best performance out of it? And the other thing is that cloud storage is wonderful to manage a super large scale amount of data and all of that. But managing data at the scale is not easy. We have some customers who are storing exabytes of data on top of GCS with trillions of objects, even from a single bucket. And when you operate data and when you have data at that kind of scale, even simple things becomes really difficult. It's like, okay, how do I find all of the objects which are created before a particular time? How do I find objects containing a particular metadata or containing a particular tag? That becomes really a finding needle from the haystack. It becomes really hard to find a lot of those things. So managing data at the scale, how do we provide those capabilities to our customers? That becomes a key requirement as well. So before I dive deep into all of the new technology, new capabilities we have launched, I want to just give people a quick overview about object storage, about the GCS. GCS, it offers 3 different location types, including regional, which is very similar to the object storage you would get from any other hyperscalers. In addition to that, we also offers dual region location type and a multi-region location type. These two location types are probably unique to GCS and to Google Cloud. Both of these location types, they provide the highest availability SLA in the industry with a 3 nines and a 5% of availability. They also offers the lowest RPO and RTO in the industry. So that for your mission critical data, for your business critical data, they provide the best data protection. For each of those location types, we also offers 4 different storage classes. This includes the standard storage classes for your normal data, the frequently accessed data, as well as some of the colder storage classes like nearline, cold line, and archive. These are intended for less frequently accessed data at a lower cost. Right? So, the nice thing about the GCS is that all of these different location types and all of those different storage classes, we give you a consistent, single global namespace and give you an instant access across all of these different storage classes. So as an application, you don't have to worry about it when we move data from one location to another location or move the data from one storage class to another storage class. At Cloud Next 2 months ago, we just announced a new storage class called the Rapid Storage class. This is intended for the high performance data, the data you are used for data intensive workload for analytics and AI workload. It provides the best performance for those type of workload. It is a zonal product, so this is a new product we just announced, which is in private preview. When we talk about the disaggregated storage, one challenge becomes to say, how can I get the flexibility and the cost benefit of disaggregated storage, but still I can easily collocate my data with my compute and also provide some of the data acceleration and the performance improvement on top of my object storage. So Anywhere Cache is a product for that. It allows customer to easily collocate storage with your compute for any of your existing bucket, for any of your existing object storage. All you need to do is go to that particular bucket and configure, say, hey, I want to turn on Anywhere Cache to accelerate my data access. And then you get this increased bandwidth throughput up to 2.5 terabytes per second, per region, per zone, per bucket. And you also get this data acceleration, reduce your latency by up to 70%. Right? And in some cases, because we cache the data, so you don't have to keep transferring the data from another region. So that can also lower your data transfer fee, data egress fee as well. So it's a wonderful product. And the best of all is that it's very easy to use. You can just turn it on any of your existing bucket, and you get that performance acceleration automatically. It's completely transparent to applications and to your end user. They don't need to know, they're talking to the same GCS bucket, nothing changes. We provide a strong consistency and everything. So it's a seamless integration with your base GCS bucket. And you can just turn it on and enjoy the performance improvement. Right. So that's a really nice product for you to go ahead and try. There's some unique value when you're using Anywhere Cache on top of a multi-region bucket. Multi-region essentially can place your data anywhere in a particular continent. And when you place Anywhere Cache on top of your multi-region bucket, essentially it allows you to cache the data in any of the zones in a particular continent. When you have that, without you having to worry about the data replication, data consistency, or data sync, and any of those things. So now this is such a powerful tool. You can say, look, a lot of the AI workload, they can never get enough of the GPUs. They can never get enough of TPUs. With this capability, essentially you can go hunt for those accelerators anywhere in the continent. Wherever there you can find the GPU capacity, you can say, hey, I'm going to turn on anywhere cache, and then I can cache my data to be close to your GPUs. And you get the best performance out of it without having to worry about moving your data yourself and replicating your data yourself. Right? For the customer who are not even using GPUs, so for example, a lot of our customers are using spot instances or spare CPU capacity in different regions at a steep discount, like oftentimes up to 80% discount. Right? So you can use the same technology. You say, wherever I can find spare CPU capacity at a steep discount, I can cache my data in that particular region and particular zone. I can reduce my compute cost by up to 80%, and I can, I don't have to worry my data. I don't have to, move my data physically, and we keep the single copy of data, keep the data consistency for you. So this is a truly wonderful technology. And I think it's also very unique and differentiated on top of Google Cloud. I encourage you to go and have a try. I talked about rapid storage early on. So this is the new offering. Essentially, it provides a disaggregated, fully managed storage system, but with all the high performance, both in terms of throughput and the latency, for high performance storage. Right. So we show some of the performance characteristics here. For example, rapid storage can provide up to 6.5 terabytes per second of throughput. This is roughly about 50 terabits per second, which is mind-boggling. For a single rapid storage bucket, you can get that type of throughput. It can support up to 20 million QPS. IOPS per second. So that's really is comparable to some of the highest performance parallel file system you can get out there. It can provide sub-millisecond latency for random read after the initial file open, and sub-millisecond for append write. So this is really, if you want to build this high performance analytics or distributed database systems or high performance AI workload, this provides the extreme performance and the scale you need. And it can support exabytes of data. Right? It can support, a lot of the high performance storage, they are quite limited in terms of the capacity and everything. This one can support exabytes of data. Right? So this is one still in private preview. We just announced it 2 months ago. So if you're interested, feel free to reach out. We can get you allow listed and give you, let you to give it a try and see how it works for you. A lot of the analytics workload, they have a lot of the file system operations, particularly about the directory operations. And for object storage like a GCS, like a Google Cloud Storage, we didn't provide native directory support. I mean, a lot of the directory support, directory operations turns out to be, many operations on top of many objects, which can be slow and which cannot be atomic. So we built a hierarchical namespace bucket called the HNS bucket that provides the native support for some of the file system operations, particularly for directory operations, directory in the renames, create a directory, delete a directory, and a lot of those directory operations. So that will dramatically help any of your workload which have those type of operations. Not only is much better performance, but it also provides the atomicity, right? It's any of those things, like if you delete a directory with a million objects, either all of those 1 million objects will get deleted or nothing happens. So that's the atomicity, that's the kind of consistency which was really hard to get from object storage in the past. So now we have that capability. In addition to that, it provides the hash sharding, which allows you to scale your QPS intensive workload much better. It starts with 8x of a higher QPS to begin with, and because of the hash sharding, it can also scale much better without hotspotting in any of the prefix keys or object names. Right? So it's another wonderful thing. When you create a GCS bucket, you can select whether you want it to be flat namespace bucket or hierarchical namespace bucket. And if you choose hierarchical namespace bucket, you get all of the benefit I just talked about. Last but not the least, I talked about the challenge of managing larger scale storage when you are dealing with exabytes of data and the trillions of objects, right? Storage intelligence is the platform to store all of the object metadata in a data warehouse and allow customers to easily search, query, and find the insight you need. And after you find those insights, we allow you to take action based on those insights. Whether the action can be a batch operation to update a lot of the storage classes, or to update the metadata of the object, or to do some cost optimization based on your insight. Right? So storage intelligence is such a platform which make managing large scale data set very easy and very intuitive. You can even use a Gemini assistant where you can use ask questions in natural language and get your insight and get your answer quickly with the storage intelligence. So all of these products have been around for some time, and we have some of the largest customers who have been using and adopting these technologies and the capabilities and seeing benefit of it. Anthropic, I think you probably all saw Anthropic at the keynote this morning. Anthropic has been a Google Cloud Storage customer. They have been using Anywhere Cache to accelerate their AI workload on top of GCS. They have been using it. They love it so much that they have got rid of their homegrown DIY caching solutions. They have been adopting the Anywhere Cache as their data acceleration platform. They also have been using storage intelligence pretty much for all of the objects, for all of their data assets. This has allowed them to get insight from 85 million of objects that they have, to get those insights and manage those objects very easily. There's another capability. I have not spent the time talking about it. It's called auto class. This will automatically manage your storage based on how frequently they get access. So Anthropic has been using pretty much put all of their objects under auto class management. In the last 9 months, they have been able to reduce their storage cost by 50%. Right? And this is, by the way, this is another easy button you can click on, you can turn on at the bucket level, and it's completely transparent to your user and to your applications. So I think in the last 20 minutes, we have covered a lot. I wish we had got more time, but to sum it up, I want to close with some of the best practice and recommendations in terms of how you can build the best data lake on top of Google Cloud Storage. If you want the highest availability and the best resilience in the industry, I would recommend use Google Cloud Storage dual region or multi-region bucket. Right? That provides, as I shared, the highest availability and the best RPO and RTO in the industry. We talked about Anywhere Cache. You can turn that on to accelerate any of your existing data access. There's also hierarchical namespace bucket, which can allow you to scale your QPS much faster and much higher. It also provides much better performance for directory operations. We talked about the rapid storage, which is really ideal for extreme performance with the disaggregated storage. We talked about the management, like how storage intelligence can help you to manage your data at scale with like a simplicity and ease of use. There's another key capability I didn't have time to cover a lot. This is called bucket relocate. Essentially, we allow you to relocate a bucket from a particular region to another region, or from a particular location type to a different location type without changing any of your endpoint or global namespace, without changing any of your storage object metadata, right? We preserve all of that. So the beauty of this is like it gives you, a lot of flexibility without interrupting your user's workflow or disrupting your applications, because nothing changes to your user or to your application. And speaking of cost, we talked about the auto class can help you manage the cost. We talk about you can use multi-region and anywhere cache to help reduce your TCO, because it can help you save so much money from your compute side and from your data egress cost. And we talk about using regional bucket, we're using different storage classes to help you save your cost on Google Cloud Storage as well. So that's a quick summary of how you can build the best open data lakehouse on top of GCP, on top of Google Cloud Storage. I hope that you find it useful, and I encourage you to give it a try.